Hi everybody, my name is Ryan Eisenberg and today we're going to talk about AWS CDK Best Practices from the trenches. So I started to work with CDK back in 2020 and I had the privilege of speaking at the first AWS CDK day, and I spoke about how CDK helps us at CyberArk to really accelerate the development of serverless applications and how awesome it is to write code for defining my resources. And the more I worked with CDK, the more I realized that we're running code, so it's very powerful. We can do whatever we want. Now, the thing is, with powerful tools, it's really easy to make mistakes. And as Uncle Ben says, with great power comes great responsibility. So you need to really understand what you're doing so you don't make mistakes. And this is what my talk is all about, best practices. So we're going to talk about CDK application guidelines, construct guidelines, security guidelines, resilience guidelines, and some general development tips. Now, these are my opinionated versions of best practices, but I think they are good for most people, and some of them are universal. So, a little bit about myself. I'm a principal software architect at CyberArk. I'm an AWS serverless hero, and I own and maintain my own website at runthebuilder.cloud. Check out the link or my QR code here. And I write about CDK, serverless, and AWS in general, so check it out. Let's start. So CDK application guidelines. The way I see it, when I start to write my serverless service, that's what I usually develop, I start with the new GitHub repository. And the main theme is that it has one business domain, should be maintained by one team to keep it simple. And then I have one CDK application, one stack, multiple constructs that might have relations between them, and one CI/CD pipeline. And that's it. Very simple, small blast readies. I've seen use cases where people have multiple applications in their CI/CD pipeline in one repository or multiple stacks, and I don't think that's right. I don't think that's the best way to do it. And why is that? Let's assume that we have multiple stacks in the pipeline in one repository. So the first stack is deployed successfully, and the tests are okay, and then you deploy the second stack and there's a problem. Now what do? Do you have like this unstable state? Do you revert the first stack? What do you do, right? So don't go there. Let's keep it simple. One CI/CD pipeline, one repository, one application, one stack, simple. So there are use cases where you want to take one of the constructs and turn it into its own stack and put it in its own repository with its own CI/CD pipeline. When do you do that? So I think the rule of thumb is when a different team is going to take care of that construct and turn it into its own service or microservice, or this construct is becoming bigger and it has its own business domain, so that's a good use case. But it comes at a price, right? So you don't want to oversplit things because it increases the development complexity when you develop features across multiple repositories. So you need to synchronize the changes, perhaps use feature flags, things like that. It gets more complicated if instead of doing everything in one stack. And in some cases, you need to share in deployment time parameters. Let's say you have a stack for Aurora and it's a cluster, and you need to share the port and the domain of that Aurora cluster with another stack in another repository that uses that cluster. So it becomes more complicated, but it can be done. You can use SSM, you can use Cloud Map during the deployment in CDK to solve these dependencies. Right, let's talk about project structure. Now, I've seen lots of variations across that. The way we do it is we have a folder for our CDK code, our service code, the business domain, and we have a folder for tests. So you have, for testing, you have unit tests, integration tests, and end-to-end. And if you want to check out how I do that and what the reasoning behind that, you can check out the QR code from my blog post about it. And for security and CDK tests, we're going to check it out in a few moments later on in this slide. So now that we understand how the project looks like, let's say that we want to create another project, right? We want to create a new microservice. So one of the things that we saw at CyberArk that really accelerates development is to have a self-service template project. So it really helps us to create a new service from scratch with all the best practices in CDK, with the CI/CD pipeline, with all the business domain SDKs that you want to have, all the internal SDKs that you want to use, observability best practices, things like that, built in, simple to deploy in a click. It really accelerates the development and really helps you to create a new service instantly. So I've created my own version, an open source version. I call it the AWS Lambda Handler Cookbook. You can check out the link or the QR code and basically get started with these best practices and other best practices for serverless that I present here. So let's talk about construct guidelines. The same way that you don't write all your code in one handler, like all the Lambda functions, you don't write it in one file, don't do it in CDK. Don't define resources in the stack other than constructs. Okay, constructs are usually, I want work with constructs. That's the basic unit that you have. The stack should have constructs, multiple constructs. However, there is an exception for that. If you have, for an example, a Lambda layer that you use across multiple constructs, you should definitely define it on the stack level. But other than that, you should have different constructs. And I'm going to show the reasoning of how I define and build these constructs in a minute. So constructs, why use constructs? Because you can share them. They're very easy to share across the organization. So which brings me to the next point. Share constructs across the organization. At CyberArk, the platform engineers usually own and maintain these constructs. These are constructs that have all the best practices for security, cost, resilience. These are tested constructs that developers can use and save time, right? You don't need to reinvent the wheel every time. And now the con is that you really require good documentation and you need to maintain them. And you keep versions, right? In Python, we have versions for libraries that we share, which means that at some point, when people upgrade, they might break or delete resources by mistake. So it's something that they need to make sure that they don't do. And we're going to talk about how you make sure for backups and resilience, how to make sure that doesn't happen. So just a thing to keep in mind when you have an external dependency like that. Some examples for constructs that you want to share across the organization. Maybe you have web application firewall rules that you want to share across the organization so everybody uses the same rules. Maybe you have an SNS to SQS pattern with encryption at rest, which is not enabled by default. Maybe you want to have AWS app config, dynamic configuration constructs, or an Aurora cluster with all the security best practices, things like that that are easy to share across the organization. If you want more ideas, you can check out the links that I've added for serverless lands, CDK patterns, things like that. Okay, so we understand that we need to use constructs. We understand that we need to share them. How do we build them? How do we model the constructs? Let's take a look at this service, example service. So in this case, I have two parts here. I have the CRUD API. I have an Amazon API gateway, triggers two Lambda functions that write to an Aurora serverless cluster inside a VPC. And I have the asynchronous parts. I have an SNS with an SQS, and I have a Lambda function that is triggered from the SQS. And I have another Lambda function that is triggered from the Aurora streams. So you see there is a connection between the two parts. They have the CRUD and they have the asynchronous part, but there are two domains basically. And this is how I basically model the constructs. I have one construct for the CRUD, and I have one construct for the messaging, the asynchronous part. Now, the Aurora part, I'm gonna add as another construct because it is complicated, and I might even import it from the constructs that are shared across the organization. It is its own thing. I might even put it later on in its own repository, its own stack, because it takes like 20 minutes to deploy it. So I want to deploy it once and have all the developers use it. It's a possibility, but it's a construct that the CRUD creates, right? It's an inner construct inside the CRUD construct. So I have two constructs. I have the CRUD, I have the messaging, and they have connections between them. So this is how I would model it. Now, this is my style. You can do it however you want, as long as you can find whatever resource in the code, whatever makes it more reasonable for you to maintain it. So it's just my version of how to do that. I think it makes sense, domain-driven constructs. So let's talk about security guidelines. How do we handle secrets in CDK? We store them, we deploy them in CDK, and we consume them in runtime in our Lambda function in our service. So first of all, never, ever, ever write hard-coded secrets in your CDK or configuration files. Store them as secrets in GitHub Actions or in Jenkins files or whatever. And then when you need to deploy them, you send them to your CDK code as constructor to the stack via environment variables and things like that. And then the CDK code will basically deploy the secret to Secrets Manager as a secret or SSM as an encrypted string. And then in the Lambda function, you provide the Lambda function an environment variable of the secret name and the permission to access the secret, and then it can use the secret in a secure manner. That's how you do it. Now, when you define constructs, basically all the higher abstraction constructs like the L2, L1, sometimes they have defaults for security, right? Now, sometimes security defaults are good, sometimes they're not. It differs by the construct. And I did notice that AWS does get better at this over time. Like they added this year the S3 encryption by default for new objects. DynamoDB does encryption at rest. But if I look at SNS topic encryption, I mean, the last time I looked, SNS topic encryption at rest is not enabled by default. So you need to go and configure it. And you need to think about it, right? You need to know that, hey, I'm gonna look for any security flaws and I'm gonna fix it. So there is a shared responsibility model, right? AWS secures the cloud, but we secure the resources inside the cloud. We define them and we need to make sure that they are secured. So you need to keep that in mind always. And you can't expect AWS to do all the work for you. So make sure that you define all the resources that you define. You think about security, have security reviews, schedule penetration tests, and also you can have some automated tools like CDK NAG, which can scan your CloudFormation output before you deploy it to AWS and notify you if you have some misconfigurations. This is a great tool, and I've added the link here in the QR code and in the link here, so you can check out how I implemented it in the cookbook and just basically do the same thing. Okay, another important issue is IAM policies. I've seen that, let's take a look at this function. It creates a Lambda role that accesses a DynamoDB. And in this case, I might require I need to get an item and put an item. That's all I need from my role. But I've seen people use the inner abstract functions like grant, read, write data, and it's great. I mean, it looks very nice. It's very clean, but it's not good, right? It's not good enough because you're getting, instead of 2 extra permissions, you're getting like 11 permissions to the role. The role is not least privileged, right? So if somebody were to gain access to this role, malicious user, he would be able to create a lot more damage to your table because he has more permissions. So you don't want to do that. You want to be sure that you really understand what you're defining and it's really readable and you define only what you need for that role. So the way to do it is to use inline policies, and here I can define a document, an IAM document, and an IAM statement, and I define exactly all the actions that I need are put item, get item, on my table ARN, and I allow it. That's it, bare minimum. And I also think that if developers use this mechanism, well, they're going to understand IAM better, and it's going to make them into a better developers. That's how I see it. Let's talk about resilience. Now, each resource has its own logical ID. It's unique, and if you change that logical ID, their resource is basically the old resource is getting deleted, and a new resource is getting built. Sometimes it's not that bad. However, sometimes people might have innocent refactors in the code. They just move some code around. They think, yeah, I'm going to move one item from one construct to another. Maybe I'm going to change another ID, and maybe I'm going to change another ID. And it might be very naive, but they might have dire consequences, okay? Because In stateful resources, this means that you're basically deleting the database with all the information, like the customer data, and creating a new empty database, which is horrible. Or even if you have roles that you use for cross-account access to assume, if you change them, then you basically break production. Okay, so it's critical that people are aware that changing IDs is dangerous. Okay, and in some cases we also had issues with CDK raising an exception. Somehow that exception during deployment got caught and CDK continued the deployment. So some resources got actually deleted from the CloudFormation. It can be a table, it can be a bucket in KDP, whatever you do, right? And it really depends on how good your tests are, if you catch that. So in order to prevent that, you can write unit tests for CDK. Let's see. So in this case, I write a unit test that runs prior to deployment. I synthesize the stack into a CloudFormation template, and I ask, basically I make assertions about the CloudFormation template, and I want to make sure that some critical resources are there. I can check out that the API gateway is there. I want to check that my table, DynamoDB table, is there, and then I can make assertions on the logical ID that it does not change, because if it changes, I'm going to lose all my data, right? Not good. So this is one way to do that. Another way to add visibility to changes is to add this utility CDK diff. It basically adds another comment in your GitHub PR and tells you exactly in the visual manner what resources you're adding and what resources you're deleting. So it's really easier for the developers to understand if the creator of the pull request is making a mistake. Let's talk about backups. So let's say that somehow a resource got deleted. We also want to make sure that we have retained policies. Even if the resource is going to change IDs, maybe we don't want to delete it. We want it to have retained policy in production, right? So it's not deleted. So in production, I'd say use retain policy. So database stateful resources are not deleted. But for developer stacks, yeah, definitely delete the stateful resources. You don't need to pay for them, and there's basically no need to do that. So a simple if statement in the code, if I'm in dev state, use delete, otherwise retain the resources in production. Now, obviously you should back up your stateful resources, use DynamoDB point in time, or Aurora has a built-in backup mechanism that you can use, or even create your own scheduled backups with AWS Backup. But you also always keep that in mind that you should do that. And finally, some general development tips. If usually there is no high-level abstraction construct like a level 2 or even higher than that construct, and you don't really understand how to define the resources in CDK, you can go to the console, play around with the service, and really understand the entities and how they work together. And then it should be easier for you to write the lower-level CDK code to really connect all the entities together. Now, sometimes, on the other hand, there is a higher-level construct, but it doesn't expose all the security options or configurations that you want to use. So you kind of have to use the CFN low level. So keep that in mind. You need to do a bit more work, but it gives you more configuration and flexibility. Now, another tip that I can give is use tags. Tags are great to identify resources in your accounts that are orphaned, or just understand what service, what developer created it. So it's really great to identify resources. And I know that developers, like I said, CDK is basically writing code, and developers love to write abstractions and code. Please don't do cool factory methods and too many abstractions. It should be simple. It's infrastructure as a code. It should be readable, easy to follow. Don't make too much abstraction. I don't mind some code duplication as long as the code is readable. I even prefer it. All right, so please keep it simple. That's what I'm saying here. So I hope that it has been helpful for you. Like I said, CDK is very powerful. It's really easy to make mistakes. You need to own these mistakes. For security measures, you have the shared responsibility model, so you need to keep that in mind. For security, we saw how to do the CDK application and stack guidelines, that you should share constructs. You should definitely have a CDK template self-service, and we spoke about resilience best practices too. So thank you very much, and you can check out my website, runthebuilder.cloud. Follow me on X, right? X Twitter, and LinkedIn. So thank you very much.